Hello guys, welcome to my channel. Today we are going to discuss about the HVP90, the very old model, the power PCB, not the main PCB. This is the power board. It has the power supply and the motor drive itself, and the data should come through this cable from the motherboard, and this is the power input and this is the motor output, and that means basically this is the motor drive with power supply. Okay, let's try to understand what are the components, major components in this board, and what is the respective thing that component is doing in this board for the motor functionality. Okay, and let's begin with the power input. Basically, this is the 220 volts model, and this is the power socket. It has three pins, 1, 2, 3, and the middle one is the earth pin, and both side has the neutral and phase. It is going to fuse holder, two fuse holders. It contain uh, two fuses, and you can see this is the PCB inputs, and fuse is here to here and here to here, and the power is going through these two paths, and it is going to the line filter coil, and this is the coil, and this pin to this pin, this pin to this pin, and in the middle it has the filter capacitor, again another coil. That means there are two coils at the input side as the EMI filter, and there is a surge arresting circuit also there, and few capacitors to uh, to to the grounding also, and after that filtering with 1, 2, 3 capacitors and two coils, it is going to the bridge rectifier. Bridge rectifier is underneath, and this is the bridge rectifier, and the 220 AC volt directly coming to the this bridge rectifier. You know what is the meaning of rectifier? That means it converts AC voltages to DC voltages, and after the rectifying, it is directly going to the this bleeder resistor. It is basically 15 watt 10 ohms resistor, and the modern circuits, they use PTC for this instead of this power resistor, and basically the plus is going to this resistor, and the minus is directly going to the capacitor ground, and this is the positive, and this is the positive is coming from the bleeder resistor, this 2 point, and this is 470 microfarad for 450 volts, three capacitors in parallel, and this is the DC section, and the main power supply is done now. That means main power input is okay. Now we have 320 DC volt in between capacitor, and we need two auxiliary powers for few works to do with this the motherboard and the whole controller. We need basically 24 volts power supply for operating solenoid, 24 or 32 volts, and here is the power supply SMPS for relating that voltage, and this is the main chopper transformer, and this is the FET. Let me show you the FET, and okay, this is the FET. Basically it is 11 and 90 ampere, 90 ampere FET is there, and for driving that FET, they use special integrated circuit unit, we called hybrid unit, and this is the 2EPPCB170. Actually this is the Hoshin part number. It is exclusively available in Hoshin. I don't know how the Chinese sellers selling this one. I think maybe copy product anyway. And this one is responsible for oscillating the FET. And basically this is the oscillator, this is the oscillating equipment. And let's quickly go to the main camera. Okay. And this is the 2VPPCB170. this is the FET. And those are this is 12 volts smoothing capacitor. This is 24 volts or 32 volts capacitor. There is a jumper, this is the jumper cable. And we call JP1 is there are two positions available. We have to select this position according to output of the solenoids. It has 30 volts and 24 volts line here. And this is the port delivering 24 volts, this one, and delivering 24 volts to motherboard. And this is the signal input line from the motherboard, the main board we call. And you can see some optocouplers here. This is some optocouplers to run the IPM. This is the IPM unit, the power module. Let me show you. And this is the IPM use this board. It is MIG20J503H. This is basically 20 ampere version, and they have few other versions also, but basically this is the most of the time they are using this IGBT. And okay, let me switch to the main camera again. And okay, let's take a look with microscope. And actually this is the photocouplers. There are few photocouplers. M601. Basically there are 6 photocouplers. 1 2 3 4 5 6. This is for UVW high low couplers. U high, U low, V high, V low, W high, W low. These couplers are responsible for that. And this is for error reporting optocoupler. It is going backward. It takes signal from the IPM side. You can see the LED part of the coupler is in this side, and output is connected to this side, and it is going downward. And other couplers are receiving signals from the motherboard and drive the IPM. This is the bootstrap condensers, capacitors. There are 3 bootstrap capacitors available for UVW respectively, and 3 diodes also getting power from that IPM itself. And this is the IPM VCC smoothing capacitor. And this is the power supply for the drive circuit. The optocoupler needs some voltage to drive the couplers, and this is 78055 5 volts regulator. It is coming from underneath of the power supply. And let me show you first of the main camera first. And this is the power supply area. It is we call VD, and it has ZD1, CD1. Basically it is 14 volts, 16 volts. We received basically 14, 15, 16 volts, and it reduced to the 5 volts and give it to the couplers for the operation. And you can see the power LED here. I missed that point. This is the basically indicating the power is there or not. And there are another special FET inside here. It is for the discharge capacitor discharging circuit, and we call RF signal is coming from the CPU, and it take by this FET and discharge the capacitors when you power off the unit. This is for fuse for this resistor. Actually, we have to connect 20 watt 30 watt resistor here, 220 ohm like that, and this is the fuse for the protection for that resistor. And those are two current transformers for two phases, and another phase is going through the PCB, and there are two transformers to detect overcurrent from the IPM. If you draw overcurrent from the motor, and it will detect the overcurrent, and overcurrent circuit will be report to the motherboard. It is the motor is in overcurrent and it is going to shut down mode, and power relay is there. I forgot to mention that if the power supply is okay and the motherboard is turning on properly, this is the bypass relay for this resistor. At the beginning, this resistor is doing the PTC the job of the PTC, and if the circuit is okay and everything is fine, then the relay takes the job, and these 2 points of the resistor is going to be close, and resistor is disconnected. And this is the main power relay, and the CPU is take care of its on and off status. And this is the basic introduction of the any motor drive related to sewing machine, I mean. And if you want to know more, please like and subscribe my channel, and let me know the comments if you want any detail about this, how to test, what are the test point we are going to test, and how to diagnose the error codes according to the, the test points measurements. And we can go ahead. Please like and subscribe my channel, and see you next time.